In this lesson, we are going to discuss about parametric differentiation. Parametric equations are when variable x and y are given in terms of t. For example, y equals to 2t cubed, x equals to t squared minus 1. In order to find the derivative of parametric, we can use the formula of chain rule, where dy over dx equals to dy over dt times dt over dx. Notice that dt can be simplified in order to get back dy over dx. So, for equation y equals to 2t cubed, we will differentiate y with respect to t equals to 6t squared. For equation x equals to t squared minus 1, we will differentiate x with respect to t equals to 2t. Let us see the example here. In formula, we need dt over dx. Therefore, we need to inverse dx over dt in order to get dt over dx, which is equals to 1 over 2t. Finally, dy over dx equals to 6t squared times 1 over 2t equals to 3t. For second derivative, we have to differentiate dy over dx once again. Let us recall our previous result. Dy over dx is equals to 3t. In order to get second derivative, we will use chain rule, where we will differentiate dy over dx with respect to t times dt over dx. So, for our example, differentiate 3t will equals to 3, and then we will take back the previous value, dt over dx is equals to 1 over 2t. Finally, we can get d2y over dx squared equals to 3 times 1 over 2t equals to 3 over 2t. Let's say, if our dy dx is equals to equation that in terms of x, then we can get our second derivative straight away. But for this parametric equation, remember, we need to differentiate it by using chain rule. Let us be alert with the correct concept here, where y equals to 2t power of 3, differentiate y with respect to t equals to 6t squared. There's always a wrong writing here, where they're doing differentiation on y equation, they're writing as dx. We cannot differentiate with respect to x because there is no term of x in this equation.